Sound familiar? Could be the alternator, it may be the battery. We're going to check out the alternator, but first we need to start with the battery and make sure the battery's in good shape. In order to do that, we're just going to do a visual inspection. That's the first thing to do. Just take a look at the battery, make sure the terminals are tight, make sure there's no corrosion, check it for leaks, and check your hardware for the hold down. Make sure it's all in good shape. This one looks like it's in good shape. Now, if it was dirty, you may want to put some cleaner on there. Go ahead and clean up the terminals. You can actually use these tools right here, take them off, clean up the terminals, make sure there's no corrosion. Later, we're going to look at voltage drop. When we go to the alternator circuit, we don't want any voltage drop, and even from the cable here, you could have a voltage drop which could cause a problem. When you put it all back together, you want to make sure you use some dielectric grease, make sure you're making a good connection on the actual terminals. Now, the first thing I want to do is I just want to measure the OCV, open circuit voltage of the battery. Now, I got my meter right here. I'm going to set it on the battery. I'm going to go across the terminals, the negative on the negative, the positive on the positive. Now, I want to see 12.6 or higher, so I can go ahead and test the battery and make sure if it's any good. So if I go across it right there, wow, this one's showing 10.9. Now listen, you have to charge the battery to its full potential before you condemn the battery. Then we can turn our attention to the alternator. Chase, you've been charging one up over there.
Yeah, I got one fully charged, and you know what, John? I got a tester right here. I want to go ahead and test the battery I got, so we know it's in good shape.
Now this is a conductance tester. You can use a load tester to do this, but this one kind of does it all automatically for you. It's pretty easy to use.
Yeah, you're just going to take your positive, hook up to the positive side of the battery, and negative to the negative. And then all we have to do is follow the prompts. And the first thing it says is out of the vehicle, and this is what we're doing. Our battery's out of the vehicle. So we'll hit go, and it wants to know what kind of battery. Is it conventional or is it AGM? This is an AGM battery, so we'll click down, showing our voltage there, and press go. Now it wants to know the cold cranking amps. And you just come over to your battery, look at the label. Ours is 750, and it's already there. Let's hit go. Yeah, the engine's off. We're not even in the car. Press enter. Now it's doing the first load.
Now it's load testing the battery. Now if you're using a carbon pile load tester, you want to go ahead and take that cold cranking amps, you want to cut it in half. Once you cut it in half, you want to load test it for 15 seconds, and it doesn't want to drop below 9.6 volts. This one looks like it's working.
Yeah, our battery is good. Open circuit voltage is 13.3. Our cold cranking amps is actually 944. This battery's in excellent shape. You know what we need to do? We need to get it installed so we can keep performing these tests on the alternator.
That's what we'll do. Now the alternator belt is a critical part of the system, and it has to be checked, and it has to be checked thoroughly. Think about it for a minute. If this belt's too tight, it's pulling down on that bearing, it's causing problems in the alternator. If it's too loose, it could be slipping, introducing heat into the bearing, and more importantly, if it's slipping, it's undercharging. It's not doing its job. So to check the belt, I want to show you a couple of tricks. Now the first one, you can use a spray bottle of water. Just be careful, have the car running, spray it on its longest span. Just put a little bit of water on it on its longest span. Now what's happening is the water is acting as a lubricant. If the squeal gets louder, it's probably a tension issue. If the squeal goes away for a minute, comes back, that's probably a tracking issue. But this is a quick little test that you can use. Just be safe doing it. Now you can also get a belt tension gauge. This is pretty cool because this belt tension gauge, you can put it on the longest span of the belt. And this will really tell you what's going on with the tension, because tension issues are big problems when it comes to alternator slipping. So if I come over here, you can see right here where I open it up. Once I open it up, I just slip it over the longest span. And when I slip it over the longest span, you can see the gauge right here. And the gauge is actually telling you it's a used belt. It's almost in the red, so it's almost time to replace this belt. Once again, slipping, under charge, putting heat into the alternator. Not a good thing. Well, what controls tension? Well, I have a tensioner right here. It's located down in this Mustang down there, but it's a tensioner like this. Now, you want to check the bearings of this. You want to make sure the spring's good and you have good tension on it. Anytime these bearings come loose, you're going to have tracking issues, but more importantly, the belt's going to end up being loose. It's going to do a lot of damage to the alternator. Now to check the belts, well, that's all changed as well. Remember the old days? We used to have these neoprene type belts right here. Well, if you see this neoprene type belt, you could actually squeeze it and you could see the cracks. You used to count them in a specific area and you could tell if the belt was good or bad. You can't do that anymore. They're EPDM belts. Well, what does that mean? Well, it's a special material. It kind of wears like a tire. As it wears in the grooves, it gets deeper and deeper and deeper. So in order to check those, I got a couple of belts here I want to show you. I have a worn belt, I have an age belt, and I have a brand new belt. And you go get a tension gauge like this, or actually a checker that goes into the belt, and it can actually see if the belt's good or bad. So if I go down in this belt right here, now this worn one, it goes way inside of there. and you can't even feel it protruding out because it's so worn in these grooves. Well, what's happening there? It's going around that pulley, it's not making good contact, it's introducing heat into the pulley, it's doing damage. Now my aged one over here, it's sticking out a little bit, but it's really not protruding out of the top too much. And I come over to the new belt right here, and it's sticking way out the top. Now this one's going to track right, it's going to ride right, it's not going to introduce any heat into the alternator. So once you make sure the belt's in good shape, then we can turn our attention to checking the voltage output and voltage drops. Well, we're ready to test the alternator for output and voltage drops. But before we do so, we have to understand how an alternator works. And I have a schematic right here. You can take a look at this graphic. And on the schematic, you can actually see you're going to get power, 12-volt source at two places. The first one's the black and orange. That's the B+. That's the big wire back here on the alternator. That's the B+ wire. Now remember, this is hot no matter what. Key off, key on, this is going to be hot, so you want to be careful with that wire. Now our other one is the yellow with the green. That's a fuse coming down from the power distribution. That one's located right here. That's going to actually power up the whole field in there. We have to have power at two places. So if I take our voltmeter and I set it up to volts, DC volts that is, and I come across, I want to make sure I have power, so I'm going to put the negative on the negative battery terminal. I'm going to use that as ground. I'm going to come on here to the yellow wire, and I'm going to go down inside of there and make sure that I have. That's good. I got 13, 12, 9, but that's fine. We have appropriate voltage to that terminal. Now I want to come back and be careful where you're touching that you don't short anything out and touch the lead going to the alternator, the big bat wire, and we have voltage there. So that tells us we have voltage present to the alternator, so the alternator should be doing its job. Now we can also do another test called voltage drop. This is very important. This is checking for resistance. Although we have voltage, there may be resistance in the form of wires chafing, wires getting too hot, loose connections, bad battery terminals, wrong length, wrong type of wire. There's all kinds of ways that causes resistance in the system. So what I'm going to do to check the voltage drop, I'm going to do two things. I'm going to do the positive side, which I'm going to take the lead from the positive battery terminal right here. I'm going to go to this lead right here. And then when the car's running and we're pushing the amps and the volts through, we're going to read the meter. We don't want any more than 5/10 of a voltage drop on the alternator circuit. Then what I'll do is I'll come over to the negative side, put the positive lead on the negative, and I'm going to touch the case of the alternator. Now why the case? Because it's case grounded. It's bolted to the car. So if you have any loose bolts, if it's not secure, you have any corrosion between the mounts, we have a voltage drop. Well, what is that going to do? Well, think about it here for a minute. If I'm taking the field voltage and I'm only putting 10 volts in there and it wants 12, it's going to be an undercharging condition. You're going to do damage to the battery, or if we have an overcharge condition or something going on, you could damage the actual alternator. So you want to make sure that these connections are good. I got Chase inside the car, so let's go ahead and measure these two voltage drops, and then we'll move on to using the VAT 40 and checking the output. Crank it up. All right. On the positive side, we got about 0.3, that's acceptable. And if I go to the negative and I scratch the case here, all right, we got about less than 1/10 of a volt. That's really good. So that means our alternator is secure. You can shut it off. That means the alternator is secure and I don't have any voltage drop from the cable going back to the battery. Now, if I had a voltage drop, perhaps it's charging here and it's not getting back to the battery. That's because of a loose cable. You have to do some voltage drops at the terminals. You have to come back to the alternator and you can isolate it with little pieces of voltage drop. But that's a critical measurement to make sure you're getting to full potential. Now, if we know we got a good voltage going to it, we don't have any voltage drops. Now we can use the VAT 40. Now, we use the conductance tester before, and you can see that right here. Our conductance tester is a good test to check the output of the alternator. It'll just walk you through the prompts, it'll check the diodes, and it'll check everything the VAT 40 does. We used it on the battery earlier, and it does a great job. But you know, we're going to use the VAT 40, and why do I want to use the VAT 40? So I can actually show you the amperage right here, which is really cool because you'll see it charging. We just cranked the car up, so you can see that the battery is going to be a little low. It may want to put out some amperage, we'll see that. But to hook this one up, it's quite simple. I'm just going to take the positive and the negative leads of the machine. I'm going to hook up the positive first, go across the battery, and then I'm going to hook up the negative to the negative cable on the battery right there. Now I got a couple options. I got this amp probe right here. The first thing I want to do is I want to zero it. So I'm just going to take this and I'm going to zero it. Make sure it's right there around 0. 1 or 2 amps the other way is not going to hurt, but we're at 0. Now I can take this amp probe and I can put it right here at the back of the alternator, or I can come over and catch all the negative cables going to the battery. I like to go right to the back of the alternator right here because this tells me the true story of what's going on. So if I go right there, It's going to pick up the amps, if there are amps, that are running back to the battery and it's charging up the battery. But we have to run the test to do it. So in a minute, I'm going to have Chase start the car. When I have Chase start the car, I'm going to go ahead and we're going to watch this needle right here. It should put out about 40, 50, 60. Remember, alternator only charges what a battery needs. So if the if the battery's fully charged, the alternator may only put out a little bit. That's okay. But if a battery needs it, especially when you first crank it up, it's going to charge a little more. So watch that. After we watch that, we make sure it's charging. I'm going to come down here. I'm going to switch it to diodes. When I switch it to diodes, this little green or blue scale inside of there, we want to make sure the diodes are in good shape. So once again, we're going to have to run it. So when we crank up the car, watch the blue needle and watch the diodes. Go ahead. You can see 60, 50, 40, it's slowly dropping little by little because it's charging up the battery. Like I said, the alternator only charges what the battery needs. So once it starts stabilizing, now we're going to go over and we're going to shift it to diodes. And you can see the diodes falls right into blue scale. So we're in good shape. You can go ahead and shut it off. Now, you check your battery first, do your belt inspection, check your voltage drop, and then do an output test, and you can troubleshoot any alternator.